Section 3.3 is proving lines parallel. So in 3.2, we prove that if lines are parallel, then we can show that special angle pairs are congruent or supplementary. In 3.3, we're going to do the converse. We're going to show that special angle pairs can prove that the lines are parallel. So in 3.2 we were given that the lines were parallel and we talked about what happened with the angles. In 3.3 we will be given information about the angles that will allow us to prove that the lines are parallel. So let's look at a theorem. Again, this is something that will be proven. Theorem 3.4, the converse of the corresponding angles theorem. And if you remember the corresponding angles theorem, it said if two lines are parallel, then the corresponding angles are congruent. So we're doing the converse. If two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. In other words, if I am told as a given that angle 2 and angle 5, which are corresponding angles in a set of lines with a transversal, if I'm told that they are congruent, then the conclusion is that line L is parallel to line M. So by the fact that the corresponding angles are congruent, we know that the lines are parallel. It's the converse. So if we look at this, I've got four sets of lines, and I don't know which ones are parallel and which ones are not. Which lines are parallel if we are given that angle A is congruent with E? So there's angle A, there's angle E. So in this diagram, if these are to be corresponding angles, L would be my transversal, and A and B would be my two lines. I don't need M at all for this problem. So if L is the transversal and A and E are congruent, then we can say that A is parallel to B. Okay, let's look at another example. So this time I'm told that H is congruent to 3. Well, there's H and there's 3. So if H and 3 are congruent, in order for those to be corresponding angles, this would have to be my transversal. And I'm going to ignore that line because L and M are my two lines. If H and 3 are corresponding on lines L and M with transversal B, and if they are congruent, then L is parallel to M. So it's determining where we are looking and what line is my transversal versus which lines are the lines that I am trying to prove as parallel. All right, let's go to another theorem, the converse of the alternate interior angles. So again, if two lines and a transversal form alternate interior angles that are congruent, we're told that the angles are congruent, then my conclusion is that the lines are parallel. In other words, if angle 4 is congruent with angle 5, and those two angles are alternate interiors formed by a transversal, I can conclude that line L and line M are parallel. 3.6, the converse of the same side interior. If two lines in a transversal form same side interior angles that are congruent, then the lines are parallel. You notice that we're doing just the reverse of all of our theorems from the last section. So angle 3 and angle 5 are same side interior angles. And that should not be congruent. All right, hold on. I think I wrote this slide wrong. I think I did too much cut and paste. These should be supplementary, right? Same side interior angles. If two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. If angle 3 and angle 5 are supplementary, then L is parallel to M. Okay? So again, the converse of the theorem that said if two lines are parallel and cut by a transversal, then their same side interior angles are supplementary. This is the converse. And the last one, I think, is our theorem of the alternate exterior angles. If two angles in a transversal form an alternate exterior pair, and again, alternate exterior like 2, oh, I didn't even do that right, like 2 and 7, alternate exteriors, then the lines are parallel. So if angle 2 is congruent to angle 7, then L is parallel to M. Alternate exterior angles. All right, so far we've done 2 column proofs. It's the one we've done the most of. We've done a few paragraph proofs where we just write out all the words. Now we're going to look at a flow proof. A flow proof uses arrows to show the logical connections between statements, and the reasons are written underneath. We're going to use a flow proof to prove the theorem 3.5, which is the converse of alternate interior angles. So, given that 4 is congruent to 5, I want to prove this theorem, prove that if that is true, then L is parallel to M. So let's look at the way we're going to write this. We're going to write angle 4 is congruent to angle 5. That's my given. You note that I'm writing the reason underneath the actual item. I'm going to combine this with another piece of information, and I'm going to use the fact that 2 and 4 are also congruent because of, vertical angles are congruent. Okay, I'm going to combine these 2 pieces of information. I'm going to use an arrow. I should not have used that. I should have just said an arrow from there and an arrow from here. And I'm going to say that angle 2 is congruent with angle 5. What lets me say that based on these 2 pieces of information? So that's our transitive. If 2 is congruent to 4 and 4 is congruent to 5, then 2 is congruent to 5. That's my transitive. 2 is congruent to 5. And look at 2 and 5. By the corresponding angles theorem, which was a theorem proven prior to this one, I can say that L is parallel to M because if corresponding angles formed by a transversal are congruent, then the lines are parallel. So I did use one of my converse theorems to prove the other one, but that's okay because this theorem came first. So I've used that theorem to prove theorem 3.5. Okay? So that's a flowchart theorem. So keep that in mind. And what I would like you to do before you come to class is to use this chart and this information and use a flowchart theorem to prove that L and M are parallel. So do that on your own. Okay, the last thing that you'll be asked to do in this section is to talk about using some algebra. So the question here, I've got 2 angles labeled, and the question is, what's the value of x for which A is parallel to B? Now, if I don't know that A is parallel to B, there could be an infinite number of solutions here. But there's only one set of angles that would prove or that would cause A and B to be parallel. And so if I look at these are my same side interior angles, and I know that if A and B are going to be parallel, then these two angles must add up to 180. So 2x plus 120 equals 180, 2x equals 60, and x is 30. So when x is 30, I have two angles that are same side interior that add up to 180. Therefore, I can say that A and B are parallel. Okay? So that's it for the notes. Be sure you've done the proof on the prior page to the best of your ability, and we will go over it in class.